Let us solve a question on utility maximization. The question is, utility function of the consumer is given by utility is a function of two goods x and y, which is equal to x times y. Suppose price of good x and y are px is equal to 1 and py is equal to 2. These are the price of good x and y respectively. The consumer wants to spend k units only of his income. What will be his demand for good x and y? Options are being given. We need to find out the correct option. Okay, so what will be our endeavor here? We want to maximize the utility which is being given us as x times y. Okay, so consumer will try to maximize his utility subject to the budget constraint. And what will be the budget constraint? That will be price of good x times units of good x plus price of y times units of good y, and it should be equal to the amount he wants to spend. So amount he wants to spend is k here. Okay, specifically price of good x is 1, price of good y is 2. That is being given us. So we have x plus 2y should be equal to k. Now for utility maximization, we know that if I draw the graph here, so let us see, we have good x on the horizontal axis, good y on the vertical axis with the given budget line. Okay, consumer wants to get highest satisfaction. So highest satisfaction will be at a point where the budget line and indifference curves are tangent to each other. Okay, so where IC2 is tangent to the budget line will give us the optimal consumption of good x and y. That is the demand for good x and y here. Now at this point, the tangency condition, what happens at this point? So what happens? So marginal rate of substitution between good x and y is equal to the ratio of the prices, price of good x upon price of good y. Now this MRS is simply the slope of indifference curve, and this ratio, price ratio, it is the slope of budget line. Okay, now MRS, as we know, it is the ratio of the marginal utility of good x and marginal utility of good y, and it should be equal to the ratio of the prices. Specifically, MUX is simply the change in the utility due to the change in the units of good x consumed. Likewise, marginal utility of good y is the change in the utility due to the change in the consumption of good y. It should be equal to the ratio of the prices. Now this partial derivative with respect to good x means the marginal utility of good x. So du upon dx means the partial derivative of utility function with respect to x. So derivative of x is 1, so we are left with y. Likewise, du upon dy means derivative with respect to y partially, so derivative of y is 1, so we are left with x, and it should be equal to the ratio of the prices. So we know that price of good x is 1 and price of good x is 2. Solving this for y, so y will be equal to 1 upon 2 x. Now plug this value of y into the budget constraint, so we will get x plus 2 times y is this thing, 1 upon 2 times x, and it should be equal to the amount the consumer wants to spend, which is k. So 2 gets cancelled, so here we will get 2x is equal to k, or x will be equal to k upon 2, dividing both sides by 2, so we will get x is equal to k upon 2. Now what about y? So plug x is equal to k upon 2 in this equation, so y will be equal to 1 upon 2 times x is k upon 2, so we will get y will be equal to k upon 4. That means our demand function for good x and y will be equal to, so x we got is k upon 2 and y we got is k upon 4. This will be our demand for good x and y. So the correct option should be third option, that is k upon 2 and k upon 4. I hope I make myself clear in this video and you find out this video helpful. Thank you.